Hi students, welcome to SEMAS classes. Double integral. Here we are going to discuss one important topic, change the order of integration by an example problem. So this is the question, change the order of integration and hence evaluates the integral double integral 0 to 1 integral x square to 2 minus x exy dy dx. First we have to understand what is order of integration and then what is the meaning of change the order of integration. See, order of integration in the sense, if an integration involving more than one variable, we must know which variable and I am going to integrate first and then the second the other variable, that is called order of integration. See, that order of integration decides by the limits and this called inner limits. This is called inner limit and this is called outer limit. When it is double integration, the outer limit always must be a constant and inner limit may or may not be a constant, it may involve variable also. So based on this limits only the order of integration is supposed to be decided. See, here the limits involves in x, so I have to integrate this first with respect to y, then I have to integrate this with respect to x. That is the order of integration of this problem. I will repeat, the limits, the inner limits involves in the variable x, so I have to integrate this first with respect to y and then I have to integrate this with respect to x. Now go to the question. The question states that change the order, which means that, see here actually this problem I have to integrate this first with respect to y and then with respect to x, but the question states that change the order, which means that I have to integrate this problem first with respect to x and then y. We know that this is the limit of y and this is the limit of x. I cannot just like that by changing the limit to integrate, since as we know that the outer limit must be a constant. If I am changing, what we will get? I will get x square 2 minus x, that you cannot do. So how to approach this problem? Let us see. Here the limits involving in x, so therefore it is a limit of y. So here it is y is equal to x square, y is equal to 2 minus x and x is equal to 0, x is equal to 1. So this is the region where I want to integrate this function. First thing is this, and I have to draw the area bounded by these curves and lines. Then there I am going to change the order. Let us see how to do that one. For that, what I am going to do is to find the point of intersection. So this is the curve, y is equal to x square and y is equal to 2 minus x. So if I am substituting x square here, it is x square is equal to 2 minus x. I am substituting y is equal to x square in this line equation. This I can write x square plus x minus 2 equal to 0. Find the roots by splitting the middle term. We get x minus 1 into x plus 2, that is equal to 0. This implies that x is equal to 1 or x is equal to minus 2. When x is equal to 1, y is, if I am substituting here, 1 square, that is equal to 1. So there is one pair of points where these two curve cuts, and when x is equal to minus 2, if I am substituting here, y is equal to 4. The intersection points are 1 comma 1 and minus 2 comma 4. So with this limit and this point of intersection, we can plot the area. So this is the graph. Here I am going to draw this curve y is equal to x square. This is the upward parabola, y is equal to x square. Next, and I am going to draw the line y is equal to 2 minus x. We know to draw a straight line in a plane, we need at least 2 pair of points. Those pair of points can be identified easily by substituting x is equal to 0. If I am substituting x is equal to 0, then y is 2. So the point is 2 comma 0 comma 2 is here. If I am substituting y is equal to 0, then x is equal to 2. So this is the point. If I join these 2 points, this is the line, y is equal to 2 minus x. This is the way that we can draw the straight line. So let mark the point 0 comma 2 and 2 comma 0. Join these points, we get the line y is equal to 2 minus x. Next I am going to draw the line x is equal to 1 and then x is equal to 0. The area bounded by all these curves is this. This is the area which bounded by all these curves. So first we have to verify whether the area what we are plotted is correct or not. For that, take a step parallel to y axis. The lower limit of y is x square, because in a step the lower limit of y is x square, it is there, so it is correct. The upper limit lies on this line, so it is 2 minus x, so that is also correct. If I am moving the step, it will come minimum to this point. Here x is equal to 0 and here it comes maximum to this point. Here x is equal to 1. So the area what we selected is correct. Now the question what they are mentioned is change this order. So here I am integrating first with respect to y. So I am taking a step parallel to y axis. They ask us to change the order, which means that I have to integrate this first with respect to x. So take a step parallel to x axis. If I am taking a step parallel to x axis, what happened? See, look at this. Here the upper limit is on this curve, whereas here the upper limit is on this line. So I have to split this into two regions. One I want to integrate this first with respect to x. The reason is this: if I am taking a step here, the upper limit is going to be changed, whereas if I am taking a step here, the upper limit is going to be changed. Whereas when we are integrating this first with respect to y, look at here, throughout this region, your upper limit will be in this line, it won't be changed. Similarly, the lower limit is also in this curve, it is also not changed. But whereas when I am taking a step like this, the upper limit it is going to be changed, whereas the lower limit is same, but the upper limit is going to be changed. So that is why we split this into two regions. Now I am integrating this first with the region I1. I call this region by I1. So I1, the limit, the outer limit is with respect to y. The here y value is 0 and it can come maximum at this point. We know that the point of intersection of the curve is 1 comma 1. So this point is 1. So the outer limit y value is integral 0 to 1. The inner limit with respect to x, the limit is here x is equal to 0, here x is equal to on this curve, that is x is equal to root y. So it is 0 to root y, the function xy dx dy. Now here I am integrating this first with respect to x. While integrating this first with respect to x, I am treating y as constant. So it is 0 to 1 y into x square by 2, limit 0 to square root of y into dy. I am taking half 1 by 2 it is a constant, so I am taking that one outside. So it is half integral 0 to 1 y. I will substitute in place of x the upper limit, it is root y the whole square minus the lower limit 0 into dy. This is equal to 1 by 2 integral 0 to 1 y square. See, this will become y, and here is one more y. So y into y, that is y square into dy. Now integrate this, half into integral of y square dy is y cube by 3, the limit is 0 to 1. So it is 1 by 2 into, in place of y, if I am substituting the upper limit, it is 1 by 3 minus, if I am substituting y is equal to 0, it is 0. So this is equal to 1 by 6. So I1 value is 1 by 6. So this region we integrated, that value is 1 by 6. Now we are going to integrate this region. Similarly, what we did for I1, we have to write the limit for outer integral. The lower limit of y is 1, the step can come minimum at this point and it goes maximum to this point. So it is 1 to 2. If I am moving the step, it will come to maximum to this point and to this point. So it is integral 1 to 2, and the lower limit of the step is 0 and the upper limit lies on this line. Here x is equal to 2 minus y. So it is 0 to 2 minus y, xy dx dy. Now integrate this first with respect to x, it is integral 1 to 2. If I am integrating this first with respect to x, treat y as a constant. So y integral of x dx with respect to x is x square by 2, limit 0 to 2 minus y into dy, that is equal to, similarly I am taking the constant, what we did for I1, the same procedure I am following here. So it is 1 by 2, if I am taking outside, it is integral 1 to 2 y into 2 minus y the whole square minus the lower limit is 0 into dy. This is equal to 1 by 2 into integral 1 to 2 y into, I am expanding this by using a minus b whole square formula, a square minus 2ab plus b square. So this will become 4 minus 4y plus y square. Of course the lower limit is 0, so I left that one into dy. Now multiply y inside and then integrate, it is 1 by 2 into integral 1 to 2 4y minus 4 y square plus y cube into dy. So this is equal to half into, if I am integrating this first with respect to y, 4 into y square by 2 limit 1 to 2 minus 4 into y cube by 3 limit 1 to 2 plus y power 4 by 4 limit 1 to 2. Substitute the limit. So this of, I will write as it is now. So now this 2 and this 4 get cancelled, so it is 2 into upper limit, if I am substituting y is equal to 2, I will get 4 minus the lower limit, in place of y, if I am substituting 1, it is 1 minus 4 by 3 into upper limit, if I am substituting y is equal to 2, it is 8 minus 1 plus 1 by 4 into 2 power 4 is 16 minus 1. So further simplification, so 2 3s are 6, here 4 into 7, so minus 28 by 3 plus 15 by 4, this is equal to 1 by 2 into, I am taking 12 as LCM, then I have to multiply this by 12, so it is 72 minus, I am multiplying this by 4, since I am taking 12 as LCM, it is 112 plus, here I have to multiply this by 3, so it is plus 45 by 12. So it is 117 minus 112, that is equal to 5. So half into 5 by 12, or I can write this as 5 by 24. So this is I2 value. Therefore the total integration I value is I1 plus I2 which is equal to 1 by 6 plus 5 by 24. Take LCM and simplify, we get 3 by 8. So this is the answer for this problem. For similar problem, subscribe and watch my channel. Thank you for watching.